Good afternoon, everybody. Now, welcome to a new session related to Verilog HDL. So, in coming 4 sessions, we'll be discussing regarding the basic concepts which are related to Verilog HDL and the modules and ports. So, this is what we'll be discussing in this part. So, moving forward, what are the first basic concepts which are related to Verilog? So, whenever we are studying any programming language, right? First, we should understand what are the ABCDs which are related to those language. For example, if you are studying or if you're going through C programming, you should know what is the structure of a C programming, what is meant by say keyword, what is meant by identifier, what is a name tag, and how do you specify the comments. Then how do you say start off with the programming aspect, and what is meant by libraries, which all libraries have to be included, whether they have to be there or not. So those all things are the basic concepts which are related to a programming language. Then apart from that, if I want to write a statement in say C programming, so how should I write it? So if I want to declare a variable and I want to declare it as an integer, so what is the syntax, and I have to deal with that. And if I am writing a for loop or if I'm writing a while loop, what is the syntax for that, and what is the semantics, that is a meaning related to that looping. So just an example, so we should try to understand what is the syntax and semantics which are related to any programming languages. So similarly, when we are going through Verilog, right, Verilog HDL, we have to try to understand what are the basics which are related to this language. Now, in order to do that, we should try to see what are the different keywords which are available, what are the different, say, identifiers which are available, what is meant by white spaces, how they are treated, how we can declare a variable, and what are the different types of variables you can declare. For example, in previous this thing, we had seen that we had declared something as wire input, output. So those are the terminals, how we are defining it. So those all things, and and another thing, what you came across is how do you define a module. So you start with the keyword which is module, and you terminate it with the keyword end module, and within which entire logic sits in. And in that, you might be using any of the level of abstractions which you want. So that is how you go around. So we have to first deal with all these concepts, and then later on we can utilize these things in writing a programming, a programs for what logic you want to implement it. So, and in previous thing also we saw that how we can create an instance of a module. We call it as instance, we call it as object. So those all things. So those are again specifications what we have. Then apart from this, what are the different kinds of operators which are available? So this is all what we'll be discussing in this case. So now here, first basic concepts which we have to deal with, what is meant by constructs and what are the conventions. So what is construct? The name itself tells you have to construct. So that is you have to build or make something using some parameters. So you have to see which all constructs are available. That is, this is the syntactical available allowable part of the program, which is basically built with the help of the tokens which are available in the Verilog HDL. So in general, when we write using the lexical tokens, we build a allowable part of program which will be running in the intended form as per your conventions, and you try to see based on the programming language how those tokens will be utilized. So using the tokens, you are building the program. In simple, using the tokens, you are building the program, and that program will be performing some operation which will be related to say the logical aspect, whatever you want to implement. Then what are the conventions? What are the conventions? So each of the language will have its own convention. So convention is, it may be the program style or practices or methods what you are looking out for. So for example, if I have to write a comment, how do I write a comment? So what is the convention I should follow? If I have to give a variable a name, so whether I can give the variable name as VAR, or it should be capital V and then AR, or it should be underscore VAR. So these are all conventions what you can follow. Then apart from these, there are some regular conventions which they'll be specified that if I have to declare a variable, for example, in C programming, it will be like int and then the variable name and then a semicolon. So semicolon indicates that this is the termination of this statement in C programming. So convention, what you're following over here is you're following it in this form. So line or statement is terminated with the semicolon in C programming. Similarly, a similar kind of convention also fallen over here, that if I have to use a looping constructs, what are the conventions I should look out for, and what are the constructs I'll be making use in order to build that for loop. So just an example. So two things Verilog has to deal with this. What are the constructs or what are the building materials which are required to build the entire program? That is the first thing. And when I'm building this, what are the conventions I should follow? So these are the two aspects. So whether IEEE has imposed some conventions, you have to follow that. So those are the things which come in. Say for example, indentation, then comments, how do I comment? What are the declarations? How the statements goes on? What are the white spaces used? Naming conventions, so on. So these are all conventions. Now I think you all, if you have just gone through, I think you have gone through Python. In Python programming, what happens? Python programming is an indentation language. So if you're writing some function, right? For example, if you're writing something as fn and some this thing you're doing over there. So when you press enter, what happens is next line starts from this point. From this point it starts. That is, it gets indented. If you don't take indentation properly, it gives you error that there is some improper indentation happening. So these are the conventions which the Python follows. Similarly, we have some conventions over here also, that if I want to specify comments, if indents have to be used. So we'll just check out how it goes around. If I have to declare something, how do I declare it? So these are the things what happens. So in C programming, you can write a comment using only front slash star and star asterisk and asterisk and front slash. So between this, I can have the comment statement. I cannot use it in a multiple line comment. I cannot do this in C programming. So this is the convention. But in C++, how it is, if you want to comment, you can comment it in this form. That is double front slash and write the comment, single line comment. But if you want to comment multiple line in C++, you can do it using front slash asterisk. You put the comments and backslash, asterisk and front slash. So multiple line comments is possible, but in C programming, it is not possible. So this convention is not there. So similarly, what kind of conventions are present in Verilog, we have to just check out. So these are the things what we'll be looking out with respect to basic concepts. So this is an example what we had already looked in our previous session. So here you can see that I have a keyword over here. I have a keyword. I have another keyword over here. So this is also keyword. Then you can see that we are having the operators. There is an operator over here. This is an assignment operator. This is a logical operator. This is a ternary operator. That is comma. That is question mark and colon. So ternary operator. So this is the name of the module. So this is related to Verilog HDL. So here you can see that module is a keyword, then assign is a keyword. This is an operator. This is an operator. So these all things, end module is a keyword. So these all are constructs. These all are constructs. And then you can see that you have given a module name. So if I have to give a module name, what are the conventions I should follow? Whether I can have something like ampersand and the module name, whether this is allowed or not, whether I should use only underscore and have the module name. So these are the conventions what we follow. That is what is the naming conventions and other stuffs. And how do I declare the ports? How do I use this assignment operator? So those all things. So those are the conventions. And this is related to VHDL. So wherein you have to declare the library what you will be using. Then entity is the keyword what you are specifying. And then here end is the keyword. So port, what are the ports you will be using? So this one is also say a library, this thing which is obtained from here. Then in is a keyword, in out is a keyword. So these are the things. B in is the name of that variable or parameter. H out is the name of that parameter. So here bin to x is the name of this entity. So here we have module, here we have entity. So if I have to specify the entity name, what is the convention I should follow? So these are just a few things to name around. So these keywords, what you're observing, these are the constructs. Operators, what you're saying, these are the constructs. And these names, what you're saying, these have to be written as per some convention. I cannot put any this thing if ampersand is not specified, ampersand is not permitted. And if I put ampersand FUNT, then it will throw an error. So these are few things what we have to look out for. So first one, lexical conventions. There are actually 7 lexical conventions in which we have operators, keywords, identifiers, white spaces, comments, numbers, and strings. So we'll be looking after these one by one. Already we have discussed regarding this, but it is a recap of whatever we have discussed previously. So few things will be dealt slightly in more depth. Okay, that is say numbers and all numbers, strings. So these all will be dealt in a little bit in depth. So first one, another thing to note down is whether Verilog is case sensitive. Yes, it is a case sensitive language. That is, if you are writing some variable name as say you are writing input and you are writing it as IN. And somewhere if I go and type IN, so you are assigning something to X which is equal to IN. If I'm writing this and this are not same. They are different. So that is what case sensitivity implies. So be careful when when you're specifying the variables or typing in some coding aspects, right? So you should be careful when you're doing so. Accidentally, you might go for camel casing, title casing because of the habitual this thing. So you can just check out these all things. So first one, keywords. What is a keyword? Basically, keyword is a specific word which has some meaning in a given language. For example, first I'll just tell regarding say C programming. So in C programming, int is a keyword. What is the use of this word int? It helps us to declare a variable, or it gives us an identification that if I write something in this form, int a, it gives me the information that a is a variable which is of type integer, Similarly, in Verilog also we have keywords. So few keywords already you had gone through. That is module, then you had assign, then somewhere you had come across the word initial, somewhere you had come across the word always, then somewhere you had used the keyword input, then output and module. So these are all keywords and each is having some specific meaning. So these keywords are the basic building blocks of your programming. So they signify certain activity which will be carried out, initiated, or terminated. So as I specified, module is a keyword which will signify that it gives an indication that the module starts at this point, and end module tells that the module ends at or terminates at this location. So that is what it specifies. So they are kind of special identifiers, not exactly identifiers. They are special identifiers, but I cannot use them to say use them as a variables in the language because they have some specific meaning. I cannot use them anywhere. Only for that specific purpose, I'll be utilizing it. So there are special kinds of identifiers which are reserved in to which are reserved for building the constructs of the language. Generally, if you just observe the majority of the cases, we have seen that all the keywords in Verilog are in lowercase. So if anything else comes in, we can just check out what meaning it will be having. So till now, whatever we have observed, all are in lowercase, all the keywords. So example, if to name few is module. Module signifies the beginning of a module definition. That is, it is initiating the module, not initiating exactly. It is just giving the indication that the module begins at this point. Then end module, it signifies the termination of that module. So these are just a few things to name. So this is here you can see reg is another keyword, input is another keyword. So these are not keywords. Value and CLK are not keywords. REG and input are keywords. So these are the keywords which are used to define some parameters. They have some specific meaning. They have some specific meaning. So next one, we have identifiers. So what is the identifier? Now what happens is, suppose I want to declare some variables, because variables is the common term which we generally use because we are used to so many programming languages. That's why I'm using that term. So what we do is we declare some variables. So those variables, you give some name. You give some name. So that name itself becomes an identifier for that specific variable. So identifiers. So any program requires blocks of statements, signals, etc. to be identified with attached name tag. So that is in previous case what we saw. We saw reg something r. So this is a keyword. This r what is specified is nothing but the identifier. So it is identifying a particular, say, a register value. So that is what it is specifying. So identifiers are also sometimes termed as name tags. They are the name tags which are given to the variables or the parameters. So these are the name tags. The name tags are the identifiers here. Uh, so basically, they are nothing but, again, if I specify it in different form, the identifiers are nothing but the names given to the objects which are being created. So objects are nothing but instances what you're creating. So in module we had seen, but we had seen somewhere as wire W1. So this is a keyword. W1 is the name tag, which is I can specify, which is object which is related to this keyword, that is wire. So I can specify even in it that form. So this is the name tag W1 is the identifier. Then these names can be referenced in the design. That is how they have been specified, how it can be utilized. Then again, they are case sensitive as I specified. I have written the, say, lowercase w1. Somewhere if I write it as uppercase w1, then this and this, these two are totally different. They are not same. So that is what it implies. So few examples. So these are just names. They should not be keywords. That you should remember. Identifiers cannot be keywords. I cannot write something as say wire and wire. This is a keyword. I cannot give this as an identifier. So anything apart from the keywords, right, I can use it as an identifier. Clock enable gate underscore one. So again, there are some conventions. So when we are using this identifiers or how we specify it. So what are the conventions or restrictions which are imposed with the names what are given to the identifiers? So how I can define? So I can define it in this form. I can define it in this form. So you can see there is an underscore which is present. So underscore is permitted. Then what is the first letter which will be permitted? So that is what we'll be looking after in this case. So here, the first thing to note down is the first character. The first character, all the characters of the alphabet or an underscore can be used as a first character. So an underscore and all the letters from A to Z or capital A to Z, they can be used as the first letter of the identifier or the name tag. They can be the first character of the name tag or the identifier. I cannot use anything apart from that. So I can write this as underscore clock, this as underscore enable, but this one I cannot write anything apart from that. I cannot write it as and gate underscore one. So this is not permitted. First character, since it is and gate, it is not permitted. So what? So if first character is either underscore or all the alphabets, then what can be the next characters? So subsequent characters can be alphanumeric, it can be a number, it can be a alphabet, or it can be an underscore, or it can be a dollar. Apart from this, it cannot be anything else. So that is what is the convention which is followed. So here it can be alphanumeric, it can be an underscore, it can be a dollar sign. Apart from this, I cannot have anything else. I cannot have ampersand, I cannot have double ampersand, I cannot have say caret, I cannot have a tilde operator in between. I cannot have this character in between. So I cannot do that. Only permitted is dollar underscore, then A to Z, either uppercase or lowercase, and then apart from that, say 0 to 9. It can be combination. I can have 0, 1, 1, 0. I can have any of these cases. Okay. So dollar sign for the first character has some special meaning. Okay, these are reserved for system tasks. So these all things will be dealing in the later part of the sessions, not in this case here, but in later this thing we have some system directives and system tasks. So there will be dealing with all these things. So dollar sign is permitted, but it is permitted for some special case. Okay. So here we'll not be discussing regarding those. So here again, the same example, if we just take this and this are the keyword which have some special meaning, and I cannot change this meaning. So keywords meaning I cannot change. After this, what we are having? We are having these two. So this is a identifier. This is a identifier. Okay. So now what is meant by the white space characters? Now why these white space characters are used? Now basically what it does is whenever you are writing some code, what happens is you are habitual to write randomly int a here, then int b somewhere here, and after this you immediately start to write something assignment a is equal to b, b is equal to c, something you do in this form. Then you go for some checking. If a is not equal to b, something you are doing, and then for you are writing. So some things you are doing over here. Now what happens is white space are nothing but it is the enter character or the tab space what you have. Then you have new line character, then say a backslash character, then so many stuffs. So out of that, if I just see which are those, so these are the things, that is blanks, tabs, and new lines. That is a space. One is space which I have missed out here. So space, enter, new line character, it is nothing but enter itself. Then say tab space. So these are the white spaces which are available. And whenever we are using it, what we do is, if just to improve the readability of this entire code, that is how this code is managed. I want to improve the readability. Improve the readability in the sense you're not actually reading the code. What you're doing is, say this is declaration part. This is declaration part. So here you'll be assigning all the variables. Here you'll be assigning all the variables. Here you are checking the conditions. So you're doing a check. Here you are having the looping constructs. So now what you're doing is instead of just randomly writing it, first you give the declaration. You give the declaration. So you define all the declarations, and after that, say you might hit 2 times enter and give some blank space over here. And after that, you start off with the assignment operation if it is required. So you do the assignment operation. So assignment will be done here. Now, suppose if you want to declare a new variable, what you will do is you will not go randomly anywhere here. You come back here. So after this, right, you define that variable, and then you continue. You define this variable and then you continue. So what you're doing is you're intentionally introducing some white spaces in between. You're intentionally introducing some white spaces in between. This is why you're doing, you are separating these things. You're separating these things so that it becomes easy for us to identify or read through the code. Okay, declarations of variables is here, assignment is here. Then after that, after some 2 spaces, again, you have checked some condition. So this is doing some stuff. So this is terminated here. So if statement is there, if starts here, ends here. So after this flower bracket has been ended, so you again press enter 2 times. Say it is your convention, and then you start with the rest all things. So what you're doing is you are trying to make it neat and legible to read around. So white spaces are helpful in these kind of things. Now, but what happens is whenever we are pressing enter, those are not treated as line of code. So if you're writing something and you're pressing enter, so there is a blank line here, there is a blank line here. These are not treated as line of codes, whether it is for Verilog or any of this thing, it is not treated as line of code in this case. So in Verilog, it is not treated as line of space. So basically what happens is they get ignored. They get ignored, but only under certain conditions they won't be ignored. So that later we'll check out. So white spaces are basically ignored by the Verilog, but except under some conditions, that is when it separates the tokens, when it is a part of a string, we cannot neglect this. So in a string, what we are doing, we are writing A, B, C, something in this part. Here there are no spaces, but I want space to be a part of this. So it is like A, B, and C. I have three spaces. So even these three spaces are part of the string. So in this case, Verilog cannot neglect the white spaces. So here it is, say, a space. If you want tab, you can insert a tab. So this also will be treated as the characters. So in the string. So under such conditions, it is not, I cannot neglect these white spaces. Then what are the white spaces which are available? It is blanks, that is backslash T, then backslash B, then tabs, backslash T, and new lines, that is backslash N. So these are the white spaces which are available in Verilog. Then let us come to the comments part. So comments also improve code readability. Here, what they are doing is they are improving the overall readability of the program or the code which is available. But you are not reading the code over here. What you are doing is you are trying to make the code easy to read. So after this, I put a space, then I do some other stuff. After this, I put a space, then I do some other stuff. These spaces, what you're putting is intentionally to separate, say, declaration part, to separate the assignment part, to separate the testing part, something in this form. So you're separating these things. So this is what you're doing when you're using these white spaces. But comments, what they do is they help us to understand few things. They help us to understand few things. For example, if I write something in C programming as int temperature, then what I'll do is I'll check something if temperature is equal to 10 something, then I should on some fans. Okay, I'll do it in this form. Now this is easy to read, but before writing this or besides this, what I can do is I can put in comments specifying like check temperature reading, something of this kind. Check temperature reading and control fan. So something of this kind. So this is what is this doing is this is giving me the information of what this statement is about. What this statement is about. So what it is doing, it is helping me to understand the logic behind this block or this statements. So it is helping me to understand the code. So it is helping me to improve the code readability. That is what code readability implies. So comments are basically used to improve the code readability. Then how can I comment the statements in Verilog? If I have to comment a single line, I can comment it using the double front slash. So this is double front slash, and then whatever statement is there, you can put in over there. So this is used to comment single line at a time. So again, next statement, if you want, again double front slash, and then put the statement. Now there is another condition, that is if I want to comment multiple lines together, instead of commenting just single line, I want to comment a block of statements. So I can do it using front slash asterisk and put the statements, whatever statements are there. So put all the statements and you terminate this block of comment with asterisk front slash. So you can have n number of statements in between. You can have n number of statements between these two operators. That is front slash followed with the asterisk and asterisk followed with the front slash. So between these two, I can have n number of statements. All those statements will be treated as comments. So here just a few example is given over here. We have a variable a, b, logically ANDed with C. So here, what he's specifying, he's using double front slash. This comments only this line of statement, only that too from here. It is not commenting this part, it will be commenting only this part. Now here you can see that something is written and then enter is pressed and it comes over here, and here you can see these two operators are present, which tells that this entire thing is a comment. It is not part of the code. Even comments are neglected by the Verilog. They are not included in the compilation. So here, another thing to just observe is, here you can see that you have front slash star asterisk. Then what we have, this is, again I have a front slash and a asterisk. So this is not permitted. This is not permitted. So when you're doing this, be careful. So what happens is, after this statement, right, it is expected that you have to put this statement to terminate. But what is happening? I am encountering this. So this is not permitted. This is an illegal comment. So that is what they are specifying. This is an illegal comment. So in order to cater to such, I think you can go for some escape sequences. If you have to use it, I think you can go for escape sequences. So these are the things related to Verilog HDL. So in today's session, what we discussed was, we discussed what is meant by identifier and what is meant by keyword. What is meant by keyword? So that is this discussion. Keyword, then identifiers. They are also called as name tags. And what are the rules which you have? What are the conventions what we have to follow when we are declaring an identifier or when we are giving name to an identifier? So that is, first character can be alphanumeric, or sorry, first character can be alphabet or it can be underscore. Then subsequent can be alphanumeric, underscore, and dollar. Okay. And next we discussed regarding white spaces and comments. So let us wind up here for today's session. Let us meet in the next session. Thank you. So any queries from your